let's continue talking about how electrons and light are similar um, by teaching you basically the relationship between them. You ready?
Yeah.
Okay, so what did Niels Bohr said about the atom and its electron? Electrons are moving around the nucleus. The closer they are to the nucleus, the less energy they will have. The farther away, the more energy they will have. Yes, this is kind of a review. Let me go ahead and give you a metaphor that hopefully will help you understand. And then we'll go through these questions real quick. You ready? Okay, so how about using, I think we used Maddie before, so we'll continue using Maddie. So Maddie goes home on Friday, and she notices a nice sports car in front of her house, and she knows who the sports car belongs to, her rich Uncle Bill. So she goes in really excited because he's the favorite uncle. When she was a baby, he was in the house. He was when her grandparents died. Her father kind of took in his younger brother, who was Uncle Bill, and so he lived in the house with you guys for the first couple years. So he's kind of like a second dad to you. And due to his investment in technology, he became unbelievably wealthy. So he welcomes you, and he's so excited to see you, Maddie. And he hugs you, and he goes, you're my favorite. So he gives you $100 bill, Maddie. $100. Yes, $100. Does that make her sad? No, that makes her excited. And she's thinking, okay, $100. Me, Malachi, Turkey Creek, let's go for it. You guys still dating? Okay, good. So she picks you up on the way to Turkey Creek. What she does not realize is that Uncle Bill has already tipped us off, the rest of the class, that this was going to happen. So we have a drone following her and Malachi. So we're all in class here Friday evening, watching it on the big screen. We see Maddie get in the car and honk the horn, go drive over to his house and honk the horn, and outruns Malachi and gets in the car. And we're just following along all the way to Turkey Creek. So first place they go to is Five Guys Burgers and Fries. So they go in there. Our drone is hovering above, and all of a sudden, we see this yellow light come out from the windows of Five Guys. Yellow light, yellow light. So, 10 minutes later, out comes Maddie, out comes Malachi, and they get in the car, and they drive over to the next shopping center to go to Menchie's. So they both go into Menchie's, and a few minutes later, red light comes out. We see red light, red light. We record red light. Okay, so they get in the car, and then we see Maddie go over to Old Navy. They both get out of the car. An hour later, we see blue light come out from the windows of Old Navy. Blue light. So we record blue light. And then they get in the car. They get back on whatever that street is. And they turn right. And we're going, oops, they may be coming home now. Yeah, they turn left at that street. And Lovell. And yeah, they're coming. I-40, they're coming home. They're coming home. Okay, so we all decide to make it an evening. So the next Thursday, I get a call from Uncle Bill. It's Marino, yes. I'm going to give her another $100. I go, awesome. So we, with much expectancy, wait here on Friday night for the action to begin. We launch the drone. The drone is hovering over her house. Here she goes, scurrying in her with her tiny little legs over to the car, picks up Malachi, go down Pellissippi, Turkey Creek, Five Guys, Menchie's, Old Navy. We're going, well, that was boring. That's the same places that she went last week. So the following Thursday, we get a call from Uncle Bill. Sure enough, another $100. I know. How does she spend it? Five Guys, Menchie's, Old Navy. Goes home. All right, so by this time, we got it. She likes to go to Five Guys, then to Menchie's, then to Old Navy. Then I get a call from Emma's rich uncle, Tom. Uncle Tom. Okay? And sure enough, money's coming your way. So she goes alone. You have a boyfriend? She goes alone. And she's driving down Parkside Drive. I think that's the name of the road. And we're going, what's it going to be? Chick-fil-A, Five Guys. She turns right and goes into one of my favorite places, Texas Roadhouse. Hey, Texas Roadhouse. So, out from the window of Texas Roadhouse, green light. Then we see her come out, and we're wondering, where's she going to go now? Then she starts walking past her car, goes behind Old Navy, goes one block over to my favorite place in all the world, Hobbytown. Who's ever been to Hobbytown? That is a cool place. There, anything that you could ever want is there. Okay, board games. They have the little figurines if you want to play Dungeons and Dragons or any of those games where, with chips or figurines, you can buy them there. You can buy the paint to paint the figurines. There's all sorts of models. There's easels. There's canvas for painting. There's little toys, I guess, for little kids to play with. It is awesome. I would give me money, I'd spend it there. And so she goes in, and green light comes out. Green light comes out, and she gets in her car and leaves. The next Friday, Texas Roadhouse, Hobbytown. The next Friday, Texas Roadhouse, Hobbytown. All right. Finally, it's been, 6 weeks? Freddie's rich uncle calls us. I'm going, well, this has got to be interesting. So we see him get in the car, and he goes, not out of Oak Ridge, but to GameStop. Goes into GameStop. Purple light comes out. Gets back in the car with his little bag from GameStop, and he goes home. Ooh, must have been an expensive. The next week, GameStop, purple light, back home. The next week, GameStop, purple light, back home. Then I come to you on the 10th week and I say, okay, this is going to be one of the three that we've already looked at, but I'm going to put a square around the person so you cannot see the person. Based on their spending patterns, can you tell who it is? So the person, the little, square, the black square is traveling down Pellissippi. Okay, by the fact that it's traveling down Pellissippi, we've narrowed it down to Maddie or Emma. Okay, going down Parkside Drive? No? How about turns right at Parkside Drive and heads toward Texas Roadhouse? Who is it? Emma. All right. So, believe it or not, I've just explained to you how we think electrons relate to light. Okay? So, in this metaphor, Maddie represents an electron. Normally, she's close to the nucleus, her parents, because she's poor. Her uncle's rich. Her parents have money, she's poor, okay? But just because she's poor does not mean that she doesn't have some self-respect. So she may have to be in the house with her parents, but she doesn't have to be in the same room with her parents. So she stays by herself in her room texting Malachi. All right? That is what we call ground state. Ground state. That's as close to her parents, the nucleus, as the electron, Maddie, is going to get. Until rich Uncle Bill gives her some money, energy. When that electron gains energy, it goes as far away from the nucleus as it can possibly go. Notice the smile on her face. There was a smile because she was excited. We call this excited state. Now, she's not going to stay excited for very long. Things are expensive in Turkey Creek. So every time she spends money, she gets closer and closer to having to go back to ground state. She goes to Five Guys, and that's kind of expensive for one person. It's very expensive for two people, like what, $15 probably with drinks? $15. Why did orange light come out? Because when an electron spends some of that energy, it will emit the energy in the form of some sort of light. In this case, it was a little bit more than Menchie's, which was red, and it was in the orange section. So it wasn't, she didn't spend a little bit of money, she spent $15. Okay? Then she goes to Menchie's, where it's ice cream by the pound. Maddie was already full. Malachi wanted ice cream, so she bought him some ice cream. And why did we get red light? Because it was less than Five Guys. So the energy will be less. And what's less than orange? Red. And then she went to Old Navy, where she bought a couple of pants. And Old Navy is very expensive. Why did blue light come out? Okay, so once she uses up all her energy, she has to return back to ground state, where she will stay. Now, why this is so important is because just like we were able to identify Maddie by the way she spent money, we can identify any element or compound by the way it sheds light. So every element and compound will have its own way of spending the energy, spending the money. And we've recorded everything. Just like we were recording the colors that she was releasing, we were recording everything. We've recorded everything. We have it all. That is why we know that the moon Titan, which orbits around Jupiter, has a methane atmosphere. Wait, have we ever been to Titan? No. So how do we know what's in the atmosphere? Does the sun's light hit the atmosphere? Does the atmosphere absorb the light? Does it release the light back out into space? Can we read the light? Then we know what it is. We know what it is. Okay? So all we have to do, gang, is hit things with light and then read the light that is released from it, and we know what it is. We know what it is. Okay? So let's go through. So what does all of this have to do with the atom? Max Planck said that light was made up of particles traveling in waves. He was the first of the particle physicists. You'll need to remind me whether this is fill in the blank or just full on. Full on, okay. So that I know how much time to wait for. So, light is particles and waves. What he helped us understand, what he and other scientists helped us to understand, is that electrons are also particles and waves. Okay, now all the pieces were together to try to explain the relationship between electron and light. What are these pieces? Electrons travel as waves, each having its own frequency depending on its energy. Energy. Okay, so that's Maddie in her house, being close to her parents, but not too close. When electrons gain slash absorb from the environment energy, their frequency goes up and they move farther away from the nucleus. This is called excited state. Excited state. This is a temporary situation. What goes up must come down. Electrons will lose the energy they gained and eventually fall back to their original spot, which is called ground state. They do not always lose energy in one jump. Sometimes it may take several jumps. Watch as this person from Oliver Springs explains to you this.
While revolving in discrete orbits, electrons do not radiate energy, and so the atom doesn't collapse. The state of an atom with lowest energy is known as the ground state of an atom. Energy is gained or lost by an electron when it jumps from one orbit to the other. The atom is then said to be in the excited state.
Each jump refers to light being given off. This light is called a photon. Each jump refers to a light being given off. This light is called a photon. The smaller the jump, the smaller the energy. The more to the red side of the spectrum will be seen. The bigger the jump, the bigger the energy, the higher the frequency. The more on the blue side it will be seen. That is why when Maddie went to Old Navy, we saw blue light. That is also why when Freddie just went to, what do you think happened when Freddie just went to GameStop? Spent all $100 on it. Are there games that are $100? Wow. By understanding these jumps to be like going downstairs and not like going down a ramp, scientists began to understand that there was a pattern to the way electrons existed and were able to explain why different elements gave off different lights. Electrons could shed energy in jumps of one or more steps, but always in step increments. What that means by step increments is that there is a lowest amount of energy that it can shed. Okay, kind of like there is a lowest amount of money that we can lose. That money is what? No. 1 cent. That's right. So that's why it's called the quantum theory, because it was quantized. There's the smallest amount of energy. It's in groups of these steps. Okay? So what does that mean? That means you can't lose less than a penny. You can't lose a penny and a half. You can either lose a penny or you can lose 2 pennies. You can't lose anything in between. That's why it's called quantized. So, when we get black, Maddie gained energy, it's like jumping up to the top of the stairs. She can't stay upstairs. She has to come back down. And this is the way that she does it. Yeah? Okay, Freddie did that. And Emma, because she went to Texas Roadhouse, did 2 jumps. Okay? The smaller the step, the more on the red side. So that is why it's so important to memorize the EM spectrum, because if this is the smallest step, what type of light would she give off if she only took one step? No, because red actually demonstrates quite a bit of energy. You're looking at the smallest bit of energy. What is the weakest type of light? What? No, white is all the colors at once. Okay, stop thinking visible light. Visible light is in the middle of the spectrum. Think what is far beyond red. No, that would be too much energy. Radio. What if it's 2 steps? What's next? Infrared is too much energy. What? Microwaves. 3 steps? Now, Freddie. 4 steps. Visible light. 5 steps. 6 steps. Is that going to bother you? So is it possible that she could have gone up to a gumball machine and put, not anymore, but back when I was a kid, you could actually spend a penny on a gumball. Okay, they would give you like 5 or 6 gumballs for a penny. You guys don't do that anymore. It's what, a nickel now? A quarter for the little gumballs? Wow. Okay, back when I was a kid, you could put a penny in there and get 5 or 6 of the small gumballs. Now, what kind of light would come out of that expenditure? That's right. You wouldn't see the light, but radio light would come out. We can't see the light. But if you had a radio, it would squawk every time she spent the money because radio light would be released. This is what is meant by saying the energy level around an atom are quantized. Do we continue now with the fill in the blank? Or are we in a different question? Okay. So because atoms have different number of electrons and therefore different energy levels, stair steps, the combination of jumps that it can make are going to be different. The light that is emitted by all atoms are a combination of different lights corresponding to all the step combinations. In other words, like I said, their spending patterns become predictable. A little step, red light. A bigger step, blue light, right? So you can imagine that electron can take all different combination of steps. That means every electron has the potential for spending money in a different way. But what do we find? Thankfully, there seems to be a pattern to the way they spend light, which is very important because every New Year's, every July the 4th, we take advantage of them. Fireworks. So what if you want a yellow firework? What you want is to put into the explosive, into the rocket, something that releases a lot of yellow light when it goes back into excited state. That will be sodium. Any compound containing sodium is going to release a lot of yellow light. If you want green, that would be copper. In this case, I don't remember exactly. I think red is barium and the blue is strontium. So the people who work fireworks, they know about this. They know that different metals give off different lights and they take advantage of it. This is lithium, copper, and sodium. Here's what I was getting at. This represents hydrogen's 1 electron. The 1 electron. What does this mean? This means that hydrogen's one electron, when it gets excited and it comes back, will spend what kind of money? A little bit of money, then medium green sized money, and then a lot of money in blue, and then a really lot of money. So on the way down, and not necessarily in these steps, little step, medium step, big step, monstrous step down. And what we find is that only hydrogen will give off this step combination. Now, you might see another element or another compound with red, green, blue, and violet, but not exactly those. Not exactly that shade, not exactly that frequency. Only hydrogen has a 656, a 486, a 434, and a 410. So if we see it using our spectroscopes, which are just fancy prisms, spectroscopes, then we know it's hydrogen. How do we know that the surface of the sun has hydrogen and helium? The light that they give off. Yeah. We call them all neon lights, but guess what? Depending on the color, this one is probably neon over here. This yellow-orange is probably neon here. But the others can be any number of other gases. So why do we call them all neon lights? Because neon was the first one we were able to figure out how to do this with. And it just kind of caught. Just like Kleenex. Not all Kleenex. Some of them are Kroger brand, right? But we still call them Kleenex. Why? Because Kleenex was the first company. Old people will still come up to you and say, hey, can you take a Xerox of this? Or can you make a Xerox of this? That means, can you make a copy of this? Because what was the first company to come up with a copier? Xerox. Okay, so we've got not a ramp. You don't slide back down to ground state. You take jumps back down to ground state. Okay, which means that the atom must be made up of layers where they can jump in and out of. And I'll show you that here in a second. It was hoped that the electron position could be mapped out for atoms. Werner Heisenberg, I call him the party pooper because he dashed all our hopes. Heisenberg's uncertainty principle. All right, so 21. What is this mathematical model called that tries desperately to pinpoint all of the locations of the electrons? It's called wave mechanical model. It is a math model. It's math. Remember, yesterday we found out that there's no way that you could ever know the exact location. So this model uses probability to come up with the probable location. For example, Jasmine probably sleeps around 8 hours. Yes, she does. And she's probably home for another 4 hours doing homework, eating, playing with her pets. So on any given day, she's probably at home for 12 hours. Where is she for the other 12 hours? On her way to school, on her way back from school, at school, on her way to soccer practice, on her way back from soccer practice. Do you do anything extracurricularly?
Nope.
Okay, then maybe she spends 16 hours at home. Needless to say, if I was to ask the computer to randomly generate any point in time in a 24-hour period for Jasmine, and you had to bet money as to where she would be, where would you bet? No, you have to, one place. Why? Probably she's at home. If it's 3 a.m., definitely at home. If it's 5, Maybe. Okay, so probably we would say that she's at home. Think of that in these terms. This model tries to determine the most probable location of electrons, still considering that it is possible for the electron really not to be there. It could be somewhere else. Okay, so number 22, according to this model, where do electrons probably live most of the time? They live in zones, areas, layers around the nucleus called energy levels. Energy levels. These energy levels are given very creative names like energy level 1, energy level 2, energy level 3, energy level 4, energy level 5, 6, and 7. And we have yet to find an element that has electrons that living in energy level 8. But maybe one day we will. All right, so the zones around the nucleus where electrons probably live are numbered 1, 2, 3, 4, 5, 6, 7, where 1 is closest to the nucleus. So if you live really close to your parents, you would live in energy level 1. What does the quantum mechanics or wave mechanics call the areas within energy levels where electrons probably live? So there's areas within. Think of it this way. If the energy level is your town, your sub-level would be your neighborhood or your subdivision. I live in Cumberland Estates. Maybe some of you live in Briarcliff. Maybe some of you live in Emory Valley. Maybe some of you live in Glenwood. Okay, Woodland area. All these neighborhoods, right? We'll think of sublevels as a neighborhood inside of an energy level. Now, they are given even more creative names. But first of all, you need to understand that if you are in energy level 1, you only have one neighborhood. See if you can, there's a pattern here. Let's see if you can catch it. Maddie, energy level 1 has only one neighborhood. Energy level 2 has only 2 sublevels. Energy level 3 has, excellent. Emma, let's see if you know the pattern. Energy level 4 has how many? Yes. So depending on the energy level that you live in, you will know how many neighborhoods you live in, or you could potentially live in. Okay, so sublevels are given letters to differentiate them. S, P, D, F. So it's not nearly as creative as 1, 2, 3, 4, 5, 6, 7. Okay, and before you ask me, these are based on German letters. So I don't know German. I know Spanish, I know English, I know Hebrew, and I know Greek. I don't know German. The number of the sublevel in an energy level is equal to the energy level number. Maddie's already established that. So energy level 1 has only one sublevel. Energy level 2, 2 sublevels, and so on and so forth. So energy level 1 has only one sublevel, and that's S. Energy level 2 has S and P. Energy level 3, S, P, and D. Energy level 4, S, P, D, and F. Pretty cool. Energy level 5 would have S, P, D, F, and what would come after F? See the pattern. S, P, D, F. What would come after F? What would come after F? And no, S, we've already said S. S, P, D, F. What comes after F? See the pattern. S, P, D, F. What comes after F? No, we've already used those. What? No, not C. No. Folks, what comes after F? G. Oh my gosh, how hard is this? S, P, D, F, and G. G, you're right. All right, so why all of a sudden is it following a pattern after S, P? Because remember, S, P, D, F were based on German words, okay? After, when we discovered elements that could potentially have the next sublevel, the language, the international language of science shifted from German to English. So then what made sense in English to follow the letter F? They decided that it was G. G. Okay, so energy, but the fact is we have yet to discover elements that have electrons in the G sublevel. So layers, layers. So the first layer is 1s, then 2s and 2p, then 3s and 3p, and then of course would come 4s, and then 3d. Do you see the pattern? What do you mean no? 1, 2s and p, 3s and p, and then 4s, and then 3d.
Yes.
You see the pattern? No, there's no pattern. What is wrong with you people? Why is there a 4s in front of the 3d? It should be 3s, 3p, and 3d. No, we don't get the F. Okay, F would be out here somewhere. Folks, I told you, you need to just, this doesn't, there's not a lot of logic to this. It does not make sense. So you got to go with it. Okay, God. This is what chemistry is like every day for you, isn't it? Yeah, it's like, this doesn't make any sense. This is the first time that it's not supposed to make any sense. Okay, so 1s, 2s, 2p, 3s, 3p, and what would logically make sense for it to be next? 3d? It's not, it's 4s. Okay, just, hey, does this make sense to you, Bob? Good! That's all I can expect at this point. Why does it do that? Why does it do that weird 4s, 3d? You will find out, but not yet. Not yet. In reality, we do not consider GH or I sublevel because when we are mapping out electrons' probable location, we just consider them at ground state. Could some of these electrons hop into the G area in excited state? Yes. But there aren't any electrons in the ground state. It was soon discovered that there are regions inside the sublevels, just like there are houses inside a neighborhood. There are regions inside a sublevel. These regions are called orbitals. So when you think of orbitals, think of houses. When you think of orbitals, think of houses. And how many people can live in your house? It would just be 2. 2. 2. 2. 2. No, not 4, 2. Yes, 2. 2. So you would have to choose one of your parents to live with. That may or may not be a difficult decision. Probably go with the one that makes the most money. If you have 2 parents at home, go with the one that makes more money. That'll probably be to your advantage. Okay, so just you and your parent that makes the most makes more money. All right. So this is not a question, right? What's okay, 27. So this probability model actually came up with what the math model would do is it would put a point in all the locations where electrons were likely to be located. So what they found as the computer was putting points is that the s orbital appeared to look like a sphere. So as the computer started applying dots representing the electron's probable location, it started doing this. And they weren't most of the electrons were likely to be found in this zone, this spherical cloud. Spherical cloud, that's right. Okay, now with the P's, it started doing this. And this, and this. So because there are 3 P houses, and I'll go through a chart with you to determine that. Because there are 3 P houses, then there was places for 6 electrons. So they think that the P orbitals look like this flowery thing. So we say, imagine that there's a handle between them. We say that it is dumbbell. Dumbbell. Dumbbell shaped. And that's only one B, by the way, I've been told. Dumbbell, not dumbbell. Dumbbell, not dumbbell, dumbbell. Dumbbell. Okay, before we get to this, let me see, let's create this chart. Why don't you do it aside somewhere, just to see if you can kind of understand this, not really, and if you don't really understand this, then that's okay. First energy level has only one neighborhood, and that neighborhood is S. And because that S has only one house, only 2 people can live in that house. So the first floor has only 2 possible electrons living in there. The first energy level. Second energy level has 2 neighborhoods, S and P. The S neighborhood has only 2, has only one house. But in order to find the P houses, you have to add 2. You always add 2 to every subsequent neighborhood. So there's 1, and then you add 2 more. So how many people can live in the P? 6. So 2 plus 6 equals 8. So 8 people can live in the second energy level. 2 can live in the first. All right. Third floor. Third floor has how many neighborhoods? 3. S, P, D. S has how many houses? 1. Add 2. How many houses for the P? Add 2. How many houses for the D? And then fill them in with people, with electrons. So how many people can live in the third energy level? Let's see. 2 plus 6 plus 10 equals 18. I just taught it better, right? Really? Okay. What happened? Okay. Fourth floor. How many neighborhoods? S, then comes. How many houses in S? How many houses in P? Add 2. 3. How many houses in D? Add 2. How many houses in F? Add 2. So 2 plus 6 plus 10, and 7 times 2 is, so what is 2 plus 6 plus 10 plus 14? Good, Bob. That's excellent. Well, it's too bad because it will have to be learned. What's that? What? Well, now, we have 2 electrons in tiny little places we call orbitals. Who is to say that they will not crash into each other? Pauli, that's who. Pauli. Wolfgang Pauli. He was German. They used to call him Wolfie for short. Wolfie! Wolfie! All right. So, this is what he said. 2 electrons can exist in the same energy level. They can exist in the same sublevel. They can even exist in the same orbital, but they will not be living in they will not be spinning in the same direction.